Hi guys, if you are new to this channel, please don't forget to subscribe. These great minds. Today we are taking a course in statistics, hypothesis testing. Hypothesis testing. I'm sure everybody watching this video knows what hypothesis is. We've come across it because we've all taken courses in science before. So, but in statistics, the hypothesis we are talking about here is a claim that we are trying to test or prove. A claim that we are trying to test or prove. That's the hypothesis we are talking about here. It could be an opinion that is not yet proven, but we are trying to prove it. And we'll be dealing with two different kinds of hypotheses. We'll be dealing with the null hypothesis and the alternate hypothesis. So we have the null hypothesis, we're dealing with null and alternate hypothesis. We're dealing with null and the alternate hypothesis. Remember we said that hypothesis here is a claim that we are trying to prove. Okay? So you have to test the claim. So we'll prove whether to accept it or to reject it. Now, so let's take it one at a time. Let's take the null hypothesis. I think I have a tissue here. Let's take the null hypothesis and see how to set it. Now, the null hypothesis is also known as hypothesis of no difference. Okay? It's also known as hypothesis of no difference, and we say that it is also a kind of hypothesis that is already existing, what we used to believe in, what we already believed before we bring up a new claim that we try to prove, test, and see whether it's true or false. For the now is already existing. It's same as hypothesis of no difference. Okay, let's take a question, let's take a problem and see how we can set the null hypothesis from the problem. Okay, so the problem we are taking, the question we are taking is a farmer bought a maize. A farmer planted a maize. He has 2 acres, so he planted an old variety of maize in one of the acres, and in the other acre he planted a new variety of maize. So he planted an old variety of maize in one acre, the other acre he planted a new variety of maize, and we are trying to test to claim whether the new variety of maize produces a better yield than the old variety of maize. So we are trying to test whether the new variety of maize produces a higher yield than the old variety of maize. So let's put it in writing so you can understand what we are saying better. So we say a farmer planted an old variety of maize and also a new variety. Full stop. The new variety is proposed or said to produce to have produced a higher yield. So now test if or not. Okay, let's say test if this claim is true. So we have a problem here. So the farmer planted an old variety of maize and also a new variety of maize, of the maize. Now the new variety is proposed or said to have produced a higher yield. Now we are to test if this claim is true or not. Now this is a claim where we are saying that the old variety the new variety produced higher yield than the old variety. And we are trying to test if or not the claim is true. Now in every hypothesis testing, we say we have the null hypothesis and we have the alternate hypothesis. Now the first point in solving any problem, any hypothesis problem, is to set the null and the alternate hypothesis. So now we are taking the null hypothesis. So let's see how we can set the null hypothesis from this problem. Remember, we said the null hypothesis is the same as a hypothesis of no difference. Okay, so we can say hypothesis of no difference. So remember, we are dealing with yield, and the yield we are dealing with here is, yield is the same as the mean, average yield. Can represent it with the mean. Yes, we are talking about yield. We are talking about an output, which is just one average yield. If we have taken the individual yields of each per acre, individual yield per acre, join everything, find the average yield. So we use the mean. So now in statistics, null hypothesis is denoted by, the null hypothesis is denoted by H null, H starts with 0. That's what denotes the null hypothesis. So we say, remember, we are talking about the yield, and we say we can represent it with the mean. So the mean yield. So we use real to represent the yield of the old variety. So the yield of the old variety, we say this is representing yield of the old variety. So mu1 representing the yield of the old variety, and let's use mu2, which is the mean. This represents population mean, represent the yield of the new variety. So we say this is representing the yield of the old variety, and this is representing the yield of the new variety. So now remember, we said our null hypothesis is denoted by H subscript 0. So now to set the null hypothesis, we also said that it's the same as hypothesis of no difference. So we have our first yield, we are saying will be equal to the second hypothesis of no difference. So the two means we assume before we conduct the test to either prove the claim that now there was a claim, and the claim is that it is said that the new variety produces higher than the old variety. That's the claim that we had, the new variety producing higher than the old variety. But we cannot accept this claim unless we test and we prove that it is true. Okay? So because of this claim, we are to test it, or initially we believe, or what we believe is that for our null hypothesis, we believe that the new variety produces the same as the old variety. Unless proven otherwise, we can't say the new variety produces higher or lesser than the old variety. So for our null hypothesis, remember, hypothesis of no difference, so the new is the same as the old in terms of the quantity of produce they give. Okay, so in all scenarios, in many scenarios, for null hypothesis, hypothesis of no difference, so when you are dealing with two different parameters, you are conducting a test on two different parameters, then The null hypothesis is always hypothesis of no difference set in this form. Remember, we said when you are conducting hypothesis in two different parameters, you are having two different parameters, you are trying to test two different scenarios, you are trying to test two different treatments, and you are trying to conduct a test on them. The null hypothesis is a hypothesis of no difference, and always the mean of the first parameter equal to the second parameter, unless proven otherwise. You cannot prove any claim that the mean of the first is higher than the second or is lesser than the second. Alright, so for all scenarios where we are dealing with two different parameters, this is how our null hypothesis is set. In our next video, we will look at when we are dealing with other cases, when we are dealing with one parameter, just one parameter. When we are talking about one parameter, we'll deal with that in our other video, in our other studies. We'll deal with that. But for now, we are looking at basically two parameters, how to conduct a hypothesis test when you are dealing with two parameters. Alright. So this is how the null hypothesis is set. For question like, remember here we are dealing with two parameters, new variety of maize and old variety of maize, two parameters in our problem. Alright, so that's it for the null hypothesis. That's it. So whenever you have a hypothesis problem, a problem having a claim that you have to test, the first thing to do is to set the null hypothesis. And remember, it is hypothesis of no difference, represented by H subscript O, the mean of the first parameter equal to the mean of the second parameter. That's hypothesis of no difference. Alright, let's move forward to the alternate. So this is the null hypothesis. I hope you've taken note of that. Now let's move to the alternate hypothesis. Let's move to the alternate. So the alternate hypothesis. Alright. So after setting our null hypothesis, the next thing to do now is to set our alternate hypothesis. Now the alternate hypothesis is dependent on the claim we are trying to prove. That's what determines how our alternate hypothesis will be. It is dependent on the claim we are trying to prove. Remember in our first question, we were trying to prove whether or not the new variety gave more yield than the old variety of the maize. That was in the first question we were solving. So if we are to write an alternate hypothesis, it depends on the claim we are trying to prove. Okay? So that's what determines what the alternate hypothesis will be. Alright, so let's take, now under the alternate hypothesis, now you have different kinds of tests. Now when you are having a hypothesis problem and you are trying to test a claim, you have different kinds of tests to use. You can either use the one-tailed test. Now these different ways to solve. We have the one-tailed test, and we also have the two-tailed test. So conducting the test can either be a one-tailed test, it can be a two-tailed test. Now whether it will be one-tailed or two-tailed also depends on the question that we are given. Okay, so now let's take our question. Let's take the question again that we use, the example that we used in the first one to solve, to find the null hypothesis. Let's take the same example. I hope you took note of that. So we will not write it again, we'll just take it. So now we are looking at one-tailed test. How do we know that a test should be used, one-tailed should be used to conduct a hypothesis test? So now for one-tailed test, we can also say that they are specific tests. One-tailed test, we can also say that they are specific tests. So tests that involve proving of claims that are specific. Remember, we are dealing with two different parameters for this hypothesis test. Say for this video, we are looking at two different parameters. Okay, so when you have one parameter and you have another parameter and you are conducting a specific test on them, that is one this higher than the other one, or is this lower than this, is this better than this, or is this not better than this? Okay, those are specific. So when you have the problem in that form, you use 1/3. When your problem is in a specific form, find whether this is higher than this or this is lesser than this, use 1/3. So taking our example, if you can recall our example, the first example we took, we said a farmer planted an old variety of maize and also planted a new variety of maize. And we said that we are to test if because there was a claim in the question that the new variety of maize produces more yield than the old variety of maize, and we are to test if that claim is true or false. Okay, now the claim, remember, was that the new variety produces more yield than the old variety. Now we are specific there. You see, we are saying that the new produces higher than the old. So for tests like that, for problems like that, we use 1/3 test to prove the claim, to solve the claim. To solve the problem, we use 1/3 test, where we are being specific. We are saying that the new is higher than the old, and we are trying to prove it. Okay, that's the claim. So in such claim, we use 1/3. Okay, and how to set the alternate hypothesis for 1/3 test? We said it depends on the question. So remember we use mu, which is the mean. Mu represent population mean, so population mean of the yield. So the mean yield of the old variety, the mean yield of the old variety. So remember we represented the mean yield of the old variety with mu1, and the mean yield of the new variety, remember we represented it with mu2. So this is the old variety, so old variety of the maize, and this is the new variety of the maize. So old variety of the maize, the new variety of the maize. Now the claim is we are to prove or to test whether the new produces higher yield than the old. So we are to test whether this is greater than this. Okay, that was the claim. The claim is that this is greater than this, and we are testing on that. So we represent, now for the alternate hypothesis, it is denoted by H subscript A, H subscript A. So H subscript A, remember we said the null hypothesis is H subscript O, for the alternate is H subscript A. So you have our alternate hypothesis, we are setting it, putting it down, okay, saying that the alternate hypothesis is, remember that this is the new old variety, this represents the old variety, mean yield of the old variety, and remember what the claim is, we are to prove whether the new, so the claim was that the new variety produces higher than the old variety. So we are testing if whether it's true or not that the new produces higher than the old. So the mean yield of the new, which is the mu2, is higher than the mu1. So that's our alternate hypothesis, and that's what we are trying to test. Okay, that's our alternate hypothesis. So if you look here, you can see that we are being specific. Is this greater than this? We are being specific. So when an alternate hypothesis is set in this form, remember when the question is very specific, check whether this is greater than this. If you have a claim that one is better than the other, one scenario is better than the other, this is better than this method is better than the other method, it is a 1/3 test, and the alternate hypothesis is set this way. Have the mean of 1 is either greater than the mean of 2 or it might be less than. So but for the question we took, so this is the alternate hypothesis. So remember we said in hypothesis testing, when you have the problem given, the first thing you have to do is to set your null hypothesis and your alternate hypothesis. Okay, and we said that the null hypothesis is same as the hypothesis of no difference, and we said that in this of course we are dealing with two different parameters. So for the null hypothesis, you are having the mean yield or the mean of the first parameter equal to the mean of the second parameter. Okay, there is no difference between the two. That's why we say it is same as hypothesis of no difference. So we are saying no difference between the two. Mean of the first equal to mean of the second. That's for the null. And the alternate, we said the alternate, if it's 1/3, it is a specific claim that we are trying to prove. So it is either we are trying to prove a claim that one is better than the other, one scenario is better than the other scenario, one produces higher than the other, okay, one mean is higher than the other, or is lesser than the other. So we are being specific there, and we use 1/3. Alright, so that's it for the 1/3 test. And remember, we said that the alternate hypothesis, we have one tail test and we have two tail tests. So now let's go ahead and look at the two-tailed test. Let's go and look at the two-tailed. So, alright. The tail test. Alright. So it's also very important to know how and where we use the two-tailed test. Now the two-tailed test, we can also say is a non-specific test. It's just the opposite of the one-tailed test. For the two-tailed, it's non-specific. So for the two-tailed, if you are having a problem where we are not to show whether this is higher than this or the other is higher than this, all we want to find is whether there is a difference existing the two of the parameters, whether the two of the method, the two of the treatment, the two of the scenarios, whether there is a difference between them, okay, or the two of the products we are getting, whether there is a difference between them. So that in that case we use the two-tailed test. We are not being specific. We are not interested in finding out where the difference exists. We are only interested in finding out whether there is a difference between the two of the scenario, the two of the parameters, or the two of the methods. Okay, so let's use the same example that we used, but here we change the question a little bit to suit our two-tailed test. Okay, so we have the same question, and I hope you haven't forgotten the question. So let's say a man. Now let's use the same question. A farmer planted an old variety of maize, and also a new variety of maize and so you have planted an old variety of maize and new variety of maize in the same farmland, and we are testing. Okay, so we are testing if there is any difference, between the yield of the old and the new varieties. Okay, so we're taking a question. We have a problem here, and we see how to set the alternate hypothesis and also see the two-tailed hypothesis. Remember, we said that the two-tailed hypothesis is also non-specific test. We use the two-tailed when the test is non-specific. Okay, let's see. A farmer planted an old variety of maize and also a new variety of maize in the same farmland. So we are testing. So there is a claim that the old variety produces a different yield from the new variety, or there is a claim that the yield that the old and the new variety produces are different. That's the claim, and we are testing. We are to test if indeed there is any difference between the old and the new varieties of the maize. You see, here we are not interested in finding whether the old is higher than the new or the new is higher than the old. All we are interested in finding is whether there is a difference between the two of them. So we are not specific. We just want whether there is a difference between the two of them or not. So in this kind of test, we use two-tailed test. In this kind of hypothesis, to prove it or to prove the claim, we use the two-tailed test. Okay, and this is how to set. Remember, we said whenever we have a problem, a hypothesis problem, the first thing we do is to set our null hypothesis, which is the hypothesis of no difference. And we say when we are dealing with two parameters, and in this of course we are looking at two parameters. When you have two parameters or two parameters, and you have to test on them, okay, the null hypothesis remains the hypothesis of no difference. It does not change. So if we have to set our null hypothesis, which is the first thing we should do, is always the same. It's always the same. So our null hypothesis will always remain HO. So the mean, so this still represents the old. So the mean of the old variety, the mean yield or the yield of the old variety is not different from the yield of the new variety. So we are saying that the yield of the old variety and the yield of the new variety are not different. They are the same. Remember, hypothesis of no difference. That's the null hypothesis. Now let's go to the alternate hypothesis. How to set the alternate hypothesis. Now remember the claim we are trying to test. We are trying to test the claim that if there is any difference between the yield of the old and the yield of the new. We are not specific. We are just interested in finding if there is any difference. So our alternate hypothesis, let's clean this. So let's clean from here. I hope you've taken note of this. So to set an alternate hypothesis, remember we said alternate hypothesis is always denoted by H subscript A. So you have an H subscript A, and the mu still represents the mean of the old variety, and the mu2 represents the mean of the new variety. And our claim is test whether the claim is that there is difference between the two yields. So we are testing the claim. So there is difference. So if there is difference, that means the old yield is not equal to the new yield. The old yield is not equal to the new yield. This is the claim, and we are trying to prove it. Remember that the alternate hypothesis always contains the claim that we are trying to test. Don't forget, the alternate hypothesis always contains the claim that we are trying to test. Alright, so this is the claim. So now look at what we are looking at here. The claim is that there is difference between the two. The two are not equal. So when we have a claim like this, it is tested, or we test it with the two-tailed test. It is two-tailed test. We are not specific. We are only saying that there is difference between them, but what the difference is and how the difference is, we don't know, and we don't care to know. All we want to know if indeed there is difference between them. If indeed this is not equal to this, that's all we are interested in. So for that one, it is two-tailed. But remember, we said for the one-tailed, we are specific. For the one-tailed, we'll be dealing with, is this one higher than this one, or is this one lesser than this one? Is this method better than this, or is this better than that? Okay. So, but when you are just interested in finding whether or not there is difference between the two parameters we were given, or the two yield, the two scenarios we were given, or the two methods we were given, if we are just to test whether there is difference between them, we use the two-tailed test. Alright. So now let's go a bit further. I hope we are clarifying the confusions you might have had in this course. Okay. So recall the things we've looked at. We've looked at one-tailed test, and we've looked at two-tailed test. Now still on the two-tailed test. We are still on the two-tailed test. We'll go a bit further with it, and then we start solving actual problems. When we are done playing with the two-tailed test, we start solving actual problems. Alright. So now remember, we said that in this our hypothesis testing course, we are looking at two parameters. We are having two parameters. Now, we are having two parameters. That's what we are looking at here. Now, the two parameters, a sample of one could be given. Now, we have problems where you have out of the two parameters, just one sample is given, and the other no sample is given. So in cases like that, you have to use a different method to solve it. When you have the two parameters, only one sample is given and the other is not given. There's a different way of solving that. And when you have the two parameters and the sample of the two is given, there's a different way of doing that. So let's take examples where we have a two parameter and only one sample of one parameter is given and the mean of the other parameter is given. And we also take a question where we have two parameters and the samples of the two parameters or population is given. Alright, so let's take one sample. So let's look at the one sample. Let's look at the one sample. And we'll be putting down some formulas. I would like you to take note of the formulas now. So when we start solving actual examples in our next video, then you could record those formulas and we'll be using them. For now, I just want you to understand the whole concept before we start solving the problems. Alright, so we say we are looking at one sample. So one sample. So when you are conducting a test with one sample, so when you are conducting a test, okay, so we're conducting, let's put it clearly, conducting a test with one sample. So conducting a test with one sample, let's see, conducting a test with one sample. So let's look, how do we conduct a test with one sample? So we also take example of a question where we have only one sample given. Okay. So this is a question we are taking. Let's take note of it carefully. Now, the worm count. The worm count of a lamb. The worm count of a lamb okay, let's make it a bit. Let's change the question a bit to suit our one sample. Okay. So let's say a farmer. I love farmers a lot. That's why I'm using farming a lot. You know, farmers feed the world. So a farmer had 300. The farmer had 300 lambs. Let's say 3,000. The farmer owns 3,000 lambs. Let's put that in English very well. A farmer having 3,000 lambs divided the lambs into two groups. The farmer having 3,000 lambs divided the lambs into two groups. And one of the group divided the lamb into two groups. One group was dewormed. And the other group was not dewormed. One group was dewormed and the other group was dewormed. The mean, let's say the average worm count of the dewormed lamb was, it was 15. So the average worm count of the dewormed lamb was 15. And the worm count of 5 lambs selected randomly. The worm count of 5 lambs. Let's take it a bit up here. So we say the average worm count was 15. Let's come up here. The average worm count of the dewormed lamb was 15. And let's bring the question up here. Remember, we are coming from here to up here. And the worm count of 5 lambs selected at random, and the worm count of 5 lambs selected at random from the undewormed lambs is, so the undewormed lamb, we took 5 of them, so we had a data given, so lambs, so this is it. We have worm count. Have a table in this form. Let's put it. Let's make it have 18, have 27, we have 14, we have 32, 0 to 5, no, and we have 22. Okay, let's take the question again. I'll read it again in case you can't see clearly. Taking the question, so you can write it somewhere, so we'll solve it later. They say a farmer having 3,000 lambs divided the lambs into two groups. Divided the lambs into 2 groups. One group was dewormed, and the other group was not dewormed. One group was dewormed, and the other group was not dewormed. The average worm count of the dewormed lambs was 15. So the average worm count of the dewormed lambs was 15. And the worm count of 5 lambs selected at random from the undewormed lambs was 18, 27, 14, 32, and 22. So if you look at this problem carefully, you see that we are dealing with 2 different parameters. The first parameter is the dewormed lambs, and the second parameter is the undewormed lambs. But we have the average mean, or the average worm count of the dewormed lamb given. But for the undewormed lamb, a sample was taken from the parameter, and the worm count of the 5 sample was given. So you see here we have 1 sample given, but here we have the average of the whole population given. So an average or the mean was given for the other parameter, but for one parameter, which is for the undewormed parameter, we have a sample taken and it was given. So here this question is an example of 1 sample question, a question having only 1 sample. Remember, still we are dealing with 2 parameters, but the sample of 1 parameter was given. whilst the other one, the sample was not given, but the mean or the average of the parameter was given. Okay, so here we have one sample. Okay, good. So now we have not put in a claim. So now the claim we are trying to test here, our claim here. So let's take the claim. Okay, let's take the claim that we are trying to test. So we are to test if there is a difference. We are to test if there is a difference between the worm count of the dewormed lambs and the worm count of the undewormed lamb. Let's take it again. We are to test if there is a difference between the worm count of the dewormed lamb and the worm count of the undewormed lamb. Okay, so let's remember we said that whenever we're having a hypothesis problem, the first thing we do is to set our null hypothesis and our alternate hypothesis. And our alternate hypothesis, we said, is always the hypothesis that is containing the claim that we are trying to test. The alternate hypothesis always contains the claim that we are trying to test. So let's set our null hypothesis. I know we've taken note of the question. I'll clean it to get some space to set our hypothesis. Okay, let's clean it a bit. Oops, taking note of the question. Okay, so we set our hypothesis, but we said the null hypothesis of no difference, represented, denoted by HO. So having HO. Now hypothesis of no difference. So let's use then with the worm count. So you are looking at the mean, the worm count. So let's use mu. Let's use mu 1 to represent the worm count of the undewormed. We're using mu 1 to represent the worm count of the undewormed lamb, and we use mu 2 to represent the worm count of the dewormed lamb. Now remember, you're having two parameters, and we said for this hypothesis testing we are doing with two parameters, and for the null hypothesis it is hypothesis of no difference, the same as hypothesis of no difference when you're having two parameters. So for the null hypothesis we say that there is no difference between the worm count of the dewormed, the undewormed, and the worm count, the mean, which presents the mean or the average worm count of the dewormed. Okay, so these are null hypothesis. We set our null hypothesis. So now let's go ahead to set our alternate hypothesis. Remember we said that our alternate hypothesis is the hypothesis that contains the claim. So what claim are we trying to test in this question? The claim we are trying to test is that we are testing if there is a difference in the worm count of the dewormed and the undewormed lamb. So we are testing if there is a difference of the, so that means the claim itself is that there is a difference. That is the claim, and we are testing the claim if actually there is a difference. So the alternate hypothesis will contain the claim, and remember the alternate hypothesis is presented by H subscript A. So we contain the claim, and the claim is that there is a difference. That's the claim. We are testing there is a difference. So the mean yield of the mean worm count or the average worm count of the first is not equal to the average worm count of the worm. So remember we said that the claim is that there is difference between the worm count of the undewormed lamb and the worm count of the dewormed lamb. So because of the claim, that's what our alternate hypothesis is saying. It always contains the claim. Okay, so the first thing we have to do is to set the null hypothesis and the alternate hypothesis before we start solving. And remember again, we are looking at one sample test, a problem that is containing one sample, and this problem has only one sample given, and for the other sample the mean was given. Okay, so for a problem like this, we are to solving it. I said earlier on that I'll put down some formulas, and I would like you to take note of those formulas, because in our next video we'll be solving questions with those formulas. And don't forget to subscribe, so whenever I put the video you get it. and you follow up with this course until we finish it or enter a new course. Alright, so for when one sample, only one sample is given, this is a formula you use. Now we calculate the hypothesis, the test value. That's what we call the test value. Find the test value. Now when we start solving the actual problem, what we need to find is the test value. So when we find the test value, which we call the T calculator, for that we will calculate the test value, and we will do it at a certain confidence interval and a certain significance level. So we use a certain significance and a certain confidence at a certain confidence to calculate it. Okay. So but when we get to solving our next video, we'll look at that very carefully. But I just want to take note of the formula now and how to use it. Okay. So when one sample is given, this is the formula you use. To find the test value, we need a test value so that we can compare it to a critical value. So we have a test value which we call the T, presented with T. Because we are calculating it, we have quality calculated equal to, it's not very much clear. Let me change the marker to make it more clear. Okay, and we have T calculated. Okay, so T calculated equal to, find the mean of one. Remember, we say we are dealing with two samples. We are dealing with two parameters. We have one sample of one given, but we are dealing with two parameters, sample of one given. So it's one sample. I have this minus, so the mean of the first parameter minus the mean of the second divided by the standard error. So the mean of this minus the mean of that divided by the standard error. Okay, in our next video we'll we'll learn how to use the formula, but for now I want you to take note of it. And standard error, let's take it up. Let's clean this. Standard error is given by the standard deviation of the sample that was given. The standard, so you find the standard deviation of the sample divided by the root of the n, divided by the root of n. The n is the number of observation. So the sample, how many are they? How many sample was taken? So the number of samples that was taken is same as the n. If the sample, the number of samples that was taken, there we had 5 lamps, the one count of 5 lamps. So we selected 5 lamps, so the n is 5. Okay, so take more questions, but take note of the formula. Standard error is given by standard deviation divided by the root of the n. And when only one sample is given, we can use this formula to find our T test value. That's the T calculated. We say it's the mean of the 1 minus the mean of the 2. Always remember, if one sample is given, then that means the average of the other parameter will be given. Okay, and then divided by the standard error. So take it there, we'll leave it there. Take note of this formula as we're using it. But the most important thing I want you to get now is how to set the null hypothesis and how to set the alternate hypothesis, and also how to know, after setting the alternate hypothesis, to know whether it is two-tailed or one-tailed. Remember, we said that whether it's two-tailed or one-tailed depends on our alternate hypothesis. Okay, so and we said that the two-tailed test is not specific. It deals with whether or not there is difference. So whenever I have a claim to test whether or not, a claim that there is differences or there is no differences, whether or not there is differences, the alternate hypothesis is in this form, and it is two-tailed. You use two-tailed to test the claim of no differences or differences, the claim of differences. Remember, no differences is for now. So the claim of differences, you use two-tailed to test. So when your alternate hypothesis is this way, it is two-tailed. Okay. Okay, so for this problem we are having two-tailed and we are having one sample. So this is the formula for the one sample, and the two-tailed is differences. When your alternate hypothesis is just asking whether there is differences between the two. Alright, let's move. Let's take another problem that will contain two samples. So remember we say we have one sample of the one parameter. A sample from one parameter could be given, but we can also have problem where two samples will be given. Okay, so we'll take a question where we have two samples given, and we'll see how to set the null hypothesis and how to set the alternate hypothesis. And we also have another scenario where none of the sample will be given at all. Have a scenario where none of the sample will be given at all, but then the mean, average mean of each of the parameters will be given. So we'll also take that. So let's look at the two samples given. So we'll take the same question. So yeah, we'll take the same question. So I'll read it out. Take the same question, then we'll try to prove the claim. So the question we took initially was that a farmer had 3,000 lambs. Okay, a farmer having 3,000 lambs divided the lambs into two groups. Okay, he dewormed one of the group and left the other group undewormed. Okay, now a sample of 10 lambs was taken from each of the group. A sample of 10 lambs was taken from each of the group, and the data above the data here was obtained. So this is dewormed lamb. So let's use to represent our dewormed. We'll use D to represent our dewormed. We don't have a lot of space here, so D. Use D to represent our dewormed. Okay, so this dewormed worm, and this undewormed. So we use D, use D to present our dewormed. Use D not to present our undewormed. We have okay. So D presents our dewormed. So D dewormed, and we use D not to present our undewormed. So D is for dewormed, and D naught is for undewormed. Let's take it again. I hope you're taking note of the question. So D presenting dewormed. So D for dewormed, and D naught. Let's put it for. So D naught is for undewormed. So we said a sample of 10 lambs was taken from the dewormed and the undewormed. A sample of 10 lambs was taken from the dewormed and undewormed. Okay, so here, and the samples, this was what we obtained. 1, 2, 3, 4. Okay, we don't have a lot of space, so let's make it a sample of 5 lambs. A sample of 5 lambs was taken from each of the group. So a sample of 5 lambs was taken from the dewormed group, and a sample of 5 was taken from the undewormed group. And remember we said the D represents our dewormed group, and the D naught represents our undewormed group. So we have here 15. We obtain here 17. We obtain here 10, 15, 10, 18, we obtain 14. Okay, that's for the dewormed. Now for the undewormed, we obtain 21, we obtain 10, 13, we obtain 19, and we obtain 20. Okay, so you see in this case, sample was taken from each of the group. So we have two samples, each coming from each of the parameters given. So here 2 samples are given. In the initial one we take the first one we took, only 1 sample was given, and the average of the other parameter was given. But for this one, the 2 samples are given. So when you have a problem like this where 2 samples are given and And remember, our claim haven't changed. The claim still remains the same. Test whether or not there is difference between the worm count of the deworm and the worm count of the undewormed lamp. The only thing that have changed here is that a sample was taken from both of them. Now we have two samples, a sample, one each coming from each of the parameters given. So here two samples is given. Now the formula to find the test value changes when two samples are given. So the test value when two samples are given changes, and I'll put down the formula again. So take note of that. In our next video, we will start solving actual problems. Alright. So we have T, which is a test value that we are calculating. So test value calculated, we say is equal to, now the mean of the first sample minus the mean of the second sample divided by the root of, divided by the square root of pooled variance multiplied by 1 over n1 plus 1 over n2. Okay, so this formula is used when we use this formula when we have two samples given. When we have two samples given, this formula is what we use. Now let's check. Now the first thing we should have done, remember, let's take the formula up there. Let's write the formula up there so you can see it more clearly. We're putting the formula back, writing the formula up there for more clear view. So we say having to find the test value. So only for the test value, this markers. So the test value calculated says equal to the mean. Says the mean of the okay, I will say is the mean. Some of these markers are having problem. Okay, the mean of the first sample minus the mean of the second sample divided by pooled variance of the pool variance multiplied by 1 over the n1. That's the number of observations we have in the first sample plus number of observations we have in the second sample. Okay, so this is how we find our test value. This is how we calculate our test value when two samples are given. So when two samples are given, this is a formula we use to calculate our test value. So take note of this formula. In our next video, we'll be solving actual questions using them. But I want you to remember something. With our test value using this formula, we could get negative. But the negative is not a problem. Just forget about negative. What we are interested in is the magnitude of the value that we are getting. And also, the test value that we are calculating, we are going to compare it to a critical value. So we're having a critical value, a critical test value that is then we'll compute using our T table. So now the critical value, if the test value that we are computing is greater than the critical value, then we can discard, or we will fail to accept the null hypothesis. Let me take it again. If the test value that we are calculating is greater than the critical value that we have, then we get the critical value, we get it from the T table. In our next video, we'll look at how to use the T table. If the test value is greater than the critical value, then we fail to accept the null hypothesis. We don't say reject the null hypothesis because we cannot say accept the alternate, say it's true. We cannot say it's actually true unless we take the whole population and we study the whole population. But because we are not testing the whole population, we are just taking a sample, we fail to accept the null hypothesis. All right. So we've looked at, I remember we've looked at how to set our hypothesis, the null hypothesis, the alternate hypothesis. That's the most important point to start from when you are having a hypothesis test. We're having a problem where you have to test a claim, which is a hypothesis. So let's not forget that. Let's keep that in mind, how to set. And we also look at how to set a one-tailed, how to know whether or not a test is one-tailed or two-tailed. And we say for the one-tailed, it is specific. You deal with one parameter greater than the other, one parameter better than the other, or not. And for the two-tailed, we are just looking at differences. Alright, we'll end the video at this point. And please, if you are new to this channel, Great Minds, don't fail to subscribe. We'll continue in our next video from where we ended. Subscribe so that any video we put out there, you get it in the comfort of wherever you are. Thank you very much. God bless.